The starting point for this presentation is a TOCHI paper which describes a simple and accurate model that tells us how likely it is that people will view dynamic web content. By dynamic web content, we mean things like suggestion lists, slideshows, tickers, hover over menus, animations, videos, anything that changes on a web page whilst the URL stays the same. Another potential title for the talk, though, could be driving future media development with empirical models. So we're going to describe the work that we did with the web, but we're also going to talk about how we're taking it forward to deal not only with web content, but also with app content and television content as well. So by future media, we mean the future of entertainment. This was a phrase that's been coined by the BBC, who are the primary television network in the UK and provide a lot of content that goes out worldwide, and they are our collaborators in the later part of this research. So the question we're asking is, can we create conceptual representations of interaction based entirely on data that we can use to develop future media provision? And the answer, we think, is yes. Probably. Reasonably confident. Okay, so the challenge is to create a model that can predict future observations. It's got to have internal validity, so it needs to reliably predict observations in the same setting. And perhaps, and this is a greater challenge, I think, it's got to have external validity, so it's got to reliably predict observations in other settings. So this work started out as a project that was designed to help people with visual disabilities access web content and audio. So at the time of the research, it started in about 2008, the project, screen readers, which read out a web page in audio, handled dynamic updates very badly. So they didn't provide a good experience at all. They often missed them out completely. So we thought, if we understood how sighted users view updates, we could hopefully translate them to audio more effectively. It became clear pretty early on that designing a controlled study to look at this issue was not going to be possible. There were a plethora of dynamic updates. We had no idea what a typical update looked like, and we really wanted to be able to deal with any of them. So we were reluctant to select particular types of content and just have a go at translating those, because there are so many differences between types of content that we really struggled with that. So we did specify some tasks at quite a high level. We asked people to do things like look for the weather forecast in New York and so on sites that contain dynamic content, but we tried not to constrain it. So we didn't constrain how the task was completed, we didn't tell people to use dynamic content, and we didn't constrain where the task was completed. If they left the website and went somewhere else, that was fine. We also asked them to do 9 minutes of browsing, so we had some data that was purely based on their own interaction and preferences. So we collected quite a lot of data. It was an exploratory study. We didn't have an idea in advance exactly how we were going to analyse the data. We did quite a lot of qualitative analysis, but we also thought it would be great to have a model that would tell us how likely it was that someone would view an update. We didn't want to do this as a function of task, because we didn't know what task the end user was going to be doing. We didn't know what sort of task they were going to be completing. It could be any task. So we wanted to sort of throw task out completely. And I think this is probably contrary to the standard HCI model of considering performance as a function of task. So we asked, can we predict whether people view dynamic updates as a function of their characteristics? We used chi-squared interaction detector analysis. This is a decision tree analysis, and we used this because we wanted to understand whether or not somebody was going to view content. So we sort of wanted to end up with a yes or no answer, which would help us translate it to audio. And the factors we entered into the analysis were the action used to initiate the content, click, hover, keystroke, enter keystroke or none, the area in centimetres squared, the duration in seconds, and we also entered participant identifier and also whether it was an addition or replacement of the content. But these last two factors weren't significant and weren't included in the final model. I should say the reason we chose these factors was basically practicality. So there are loads and loads of factors that will influence whether somebody views content on the web, but they're very difficult to quantify, and these were ones that we could actually quantify, so these are the ones that we put into the analysis. We also collected validation data in a later study. So we ran another study 2 years later, different participants, different websites. Obviously the web moved on since then anyway, and we just asked them to browse, so we didn't specify tasks in that study. So the results showed that the model predicted viewing behaviour with an accuracy of around 80%, and the best predictor was action. So automatic updates viewed only 20% of the time, keystroke, enter or hover over updates around 40%, and most click-activated updates were viewed. So why weren't all click-activated updates viewed? This is an interesting question. Well, one of the main reasons is that there are lots and lots of updates that occur in response to a click, and they're not necessarily the ones that participants were expecting. So some of them were just things like updating text fields and tiny little icons saying that something was happening. So if an update was very small, people tended not to view it, but of course the larger it got, the more likely it was that they viewed it. With other updates, the important factor was duration. So with automatic updates and with keystroke, enter and hover over updates, the longer the update was on the screen, the more likely it was to be viewed. So why does the model take this form? Area, so how large it is, and the action used to initiate it are properties of the update. So these are set by the developer. As an update increases in size, it becomes more salient. Duration is sometimes a property of the update and sometimes a property of user behaviour. So it is possible for the developer to set the duration, it would appear on the screen, but it's also sometimes a property of user behaviour. So, for example, the longer a suggestion list appears on the screen, the more likely it is to be viewed, and this is because people are pausing to view the content. So we know that if it's on the screen for longer than about 2.5 seconds, people are pausing actually to view the content, so they are controlling the duration of that particular update. Okay, so we use this knowledge to translate updates to audio. So we developed a Firefox plugin which prioritised click-activated updates, delivered keystroke-activated updates whenever there was a pause in typing, and allowed people to opt in to receiving automatic updates. And this was preferred by all participants in a blind and double-blind evaluation when compared with a Firefox baseline, which basically represented the status quo at that point in time for screen readers. Okay, so what did we learn from the study overall? Well, we learned that we can model behaviour on the web without prior knowledge of the user's task. We can predict how the user will respond to content as a function of its perceptual characteristics. And we can potentially infer activity from event and timing data as well. And of course, we also learned that we can use this knowledge to successfully create software, in this case, translating content to audio. And then we had a conversation with BBC R&D. And they said, wow, that's really interesting. Do you think we could move it beyond just describing the web and start thinking about things like television as well? So can we predict behaviour with other types of media? Can we use this knowledge to drive future media development? So what kind of things were they thinking about? Well, additional content, dynamic updates occur on television all the time. So you can see here a banner talking about who's speaking at the moment on the television. We have tickers that run across the bottom of the screen. We have red button content, so when people use their remotes to interact with television programmes. And also we now have companion screens, so people using their mobile phone or a tablet while they're watching television. And they often use this for social media or to look things up on the web, but more and more broadcasters are trying to provide companion apps that people can use with the programme that's actually on the screen at that moment in time. So we've run a couple of studies with the BBC. I won't go into the details about them now because one of them was described at a CHI workshop last year and one of them was described yesterday in an CHI presentation. So there's information on the web about those if you're interested in reading more. But I will talk a little bit about some of the results that we had back. Okay, so this is a graph taken from the second study that we ran, which is where we got people to watch a programme, a nature documentary with a companion app. And the graph shows the percentage of people who were fixating either the television, which is the top half of the graph, goes from 0 to 100, or the tablets, which is displayed the companion app, which is the bottom half of the graph, going from 0 to minus 100. So negative is more people here. So the thick black lines represent the updates that occurred on the iPad, on the tablet. And what we can see, just qualitatively looking at this data, is that these attract attention. So I tracked both the tablet and the TV, and we found that when updates appeared, people's attention was drawn to them. People caught them in their peripheral vision and looked down to see what was going on. So that was one of the things that we noticed. Dynamic updates do attract attention in this situation. We also found other characteristics were important. So, for example, we can see here there's a ticker going along the bottom of the screen. We're in a studio, and the presenter's face is being fixated, which is quite normal. It's what we expect. People tend to fixate faces. And on the other side, we can see a face is being fixated as well. So both of these clips are taken from a study where we were just looking at additional content on one screen, and they cover sort of 30-second periods of viewing. So this is the aggregated data from 30 seconds of viewing. So we can see underneath another clip with the ticker, and this time people are fixating the ticker more. And this is location footage. So instead of having a person in a studio talking directly to the camera, we've got location footage, and people seem to be more likely to look at the ticker in this situation. And if we look again at the screen displaying football scores, this is a programme which gives you updates on football scores, soccer scores, I should say, then we can see that the person who is interested in football, is interested in soccer, is interested in the scores, is looking at the updating content. And the person who had been looking at the face, in fact, was somebody who wasn't interested in football at all. So we can see that participant characteristics and context characteristics make quite a big difference. So I just want to quickly show you a clip from our experiment with the companion content. The dots on the screen, coloured dots, represent different participants. So each colour is a different participant. And what you can see in this situation is that you should look out for the presenter suddenly spotting a dolphin and shouting, there, there, there. And you can see that people's attention, which was on the companion screen, then moves over to the main screen, and people fixate quite clearly on the main screen.
Stand. Boy. On. Oh, there. Fantastic. You might come in and just ride with us. On the back. Where is he? Oh, yeah, there! Right beside us. Wonderful. Oh, he's coming underneath us right here. I can just see him underneath the water. Right behind, yes! Wow. Steve, why do they do it? Does anyone know why
No, they actually bow ride in front of whales.
In front of whales?
Yes. And it's the pressure wave that a big thing going through the water.
Oh, look at that!
And it's the...
So attention started to drift back to the ticker again, no, to the tablet again rather, when the two people started talking to each other. But we can see very clearly that we're fixating on the dolphin there, and everybody was fixating. I think that's quite interesting. So what might a companion screen interaction model look like? Well, we can see that dynamic updates are viewed, so requested, what we could call clicked updates, are very likely to be viewed, so this is when people actually request them on the tablet. And automatic updates are also likely to be viewed, and certainly in the companion screen situation it's more likely they were viewed than when we were just looking at the web model. Audio, we think, probably makes a big difference. So when the presenter shouted, there's something there, we want to look at the dolphin, that made quite a big difference to where people were fixating. And of course, context and participant characteristics make a big difference as well. So the television content itself, and also the how interested the viewer is in it, are going to make a big difference. So that's where we're up to. We're working now on pulling out these categories and trying to work out how to model all of these factors. And it's a complicated situation. So we've got ecological validity to grapple with. With the web, we can kind of assume a fairly straightforward interaction model. Somebody's sitting at their computer browsing the web. But with TV, it's, there are loads and loads of other factors that are going to influence ecological validity. We also need to think, when we're modelling, about this issue of influence. So the characteristics of the content in terms of those set by the developer, versus inference. So our initial model was quite accurate, but some of the factors were influenced by the developer and others were influenced by participant behaviour. So even though the model was an accurate predictor, we need to pull out, which are the parts where we infer behaviour and what are the characteristics of the content that actually influence it. And that's a very complicated thing to do. We want to model not according to task, because we never know quite what people are going to be doing, but we're going to model according to application instead. So at the moment we're working on things that would assist with production design software. And what's our ultimate aim? Well, obviously it's to develop a compelling media experience, and that's something the BBC are keen to do. But really for us, it's also to advance craft-based engineering with science. So we're working on future media at the moment, which is a very exciting area, but there are lots and lots of areas, I think, within technology where a craft-based approach is the norm. And if we can start to develop empirical models that can help us in terms of understanding how people perceive and understand different types of information and content, then I think that's going to make a really big difference to how we can move forwards with development. So if you have any questions, please do get in touch, and you can of course find out more on our website.